Okay, guys, now that we have seen the first session in which I've advised uh, what are the things what a layout designer needs to keep in mind before starting the layout, what are the schematic observations. Now, once you have to start doing the layout, there are certain things, there is a kind of a methodical process. If you follow that, that will actually help you do the layouts more quicker and more easier as well. Okay. And obviously, as a layout person, you would be asked by your seniors, like, okay, this is the module I'm assigning you. How much time will you take to give me this? So now you should be, now it depends from individual to individual. It depends on the complexity of the block. As a senior or as a designer, they might be having a fair amount of idea that, okay, this module takes such and such time. But you, as a layout person, should be able to assess yourself and tell them that, okay, I will take 1 day to finish this. I will take 2 days. I'll take 3 days. Right? To do all that, you need to have a fair amount of idea of what are the number of devices, what is the complexity you are dealing with for you to deliver the layout. Okay, so all those things, now that you have done your groundwork, talking to the designer, talking to the leads from schematic point of view, let's move to the layout part of it. Okay, first and foremost thing here is generate all the devices at all levels of hierarchy to get the overall area estimation. First thing is you need to figure out how big is the module, how many levels of hierarchy is this module. So what I mean to say over here is, okay, say this is your XY coordinates, okay, of your layout screen. So you need to generate all the devices, transistors, resistors, capacitors, whatever, all the devices over here which are a part of this module. Now, before you generate this, as I said, when you dig into your schematic, you would figure out that it has one or two levels of hierarchy. Okay. So whatever the levels of hierarchy, you need to do a floor plan of that level of hierarchy first. Okay, put it in a PR boundary, and then when you come to this top level, you'll be generating it. So you will be having a module 1 here, and say a module 2 here, 2, and these are all the other instances at this level of hierarchy. So first thing what you got to do is generate all the devices over here, and then automatically the other modules also would be generated. Okay, so that you will get the overall count of the number of devices, number of instances. First and foremost thing is that. So you are keeping a track of the hierarchy as well as generating the devices. Now, understand the directions of the pin at the module level. According to that, place them on the left, right. Now say, assume that this is the module number 5 is the one what you have been assigned. Okay, and there is some module talking happening over here. Okay, from this guy over here, from here there are some signals, from there here there are some signals, and there is some talking happening over here. Okay, so you need to, as I said, from the schematic point of view, you went and saw what modules are there. From the layout point of view, you need to ask your layout person who is doing the next level, where is my block sitting? How much area have I been assigned to do my block? Okay, so now he or she would have given some space for the other modules as well, along with the names. So then, based on that, you will decide where should your pins sit. You know that this particular module is over here, and these are the signals talking to this. So your pins should be placed over here. The pins which are talking to this module, the pins which are getting inputs from this modules should be placed over here. So likewise, okay, so thereby you would get an idea of the pin directions. Every time you don't have to go and ask. Looking, you can dig into the top level itself and figure out things for yourself. Okay, so once you do this, okay, next thing is, so at the layout side, let's move back here. Okay, sorry, here. Once you do that, you will figure out the pin directions where you want to keep the module. Now, based on whatever devices you have, okay, based on the signal flow, based on the devices arranged, you will be knowing what are the current mirrors, what are the differential pairs, and all the other requirements what we discussed in the previous slide over here. Now you know that these are current mirrors, these are differential pairs over here. So what you would do is you go back to your layout here. Over here, you will tend to group all the current mirrors together. Say if you've got current mirrors, you would place all the transistors here, okay, and with the dummies and the guard ring as well. Another very important thing here is you should, whenever you're doing a placement, right, you should place the guard devices in a particular matching pattern along with the dummies and the guard ring. Only then you would get a correct estimate of the area this current mirror is taking. You might just end up arranging the four devices, sharing the sources and drains over here, and you would end up shrinking your module just to show that, yeah, I have completed the module in such a small area. But when you add guard rings, that eats up some space. So whenever you are giving an area estimation, always keep in mind, do the required matching along with the dummies, place the guard ring, and then give a proper location to it. Okay, that's how you do it for other modules as well. Like say for example, you've got a differential pair over here. This is along with the guard ring. Now this is a current mirror along with the guard ring. Okay, this is some other logic over here. Okay, there is some other module sitting over here on top. These are some resistor banks over here. So all of this, you need to leave a little bit of space in between for routing as well. Don't keep it too tight so that you would end up putting yourself into trouble. So once you do this, you have a PR boundary ready for it. So thereby you will get an idea that okay, this after I do the placement matching and using the dummies and the guard rings, you know, I mean, you don't have to be too liberal as well. Something decent, keep it with a little spacing in between for you to route the signals. Okay. And then you can come to a conclusion that this is the area what my module will take. And don't give the estimation without adding the guard rings or dummies. It'll hit you back very badly. Okay. So now, and along with that, you should also have an idea of the signal flows or multiple voltages. All of these things we've seen that the first thing you got to figure out is how many power supplies do we have. So when you're doing these designs, right, you need to figure out what power supply this guy has. This is VDD1 over here, and this guy is talking is VDD2, right? So you cannot share the wells of this. Okay, these guys use different potential, these guys use different kind of a power supply to work. So you cannot have the same power mesh, you cannot share the device, you cannot have same guard ring. And another important thing, as I mentioned, if you have a hot well connection when you're doing a differential pair or any of the other connections, you need to have a separate guard ring for that particular device. You cannot share the guard ring with other devices because its bulk is different. Okay, those things accordingly you need to keep in mind, and based on the signal flow, keep in mind that your signals should flow seamlessly, right? It shouldn't go ahead, come back again, go back. It shouldn't be zigzag like this. The way you do the floor plan, inputs are coming here, this stage and this stage, next. That's how it has to be your floor plan. Okay, so now that's done. So moving to the next slide. Now, moving to that's the floor plan related stuff. Okay. And also another important thing which I just missed out is you need to ensure that, whenever you're doing these things, you need to keep an eye on the current ratings also. So if at all you have, devices working at much higher currents, then you need to leave some space for your metal power mesh as well. Keep that in mind. But ideally, in the lower technologies, we wouldn't have to do that because you will be routing over the devices itself. Okay. So now let's move to the routing guidelines over here. Okay. For a leaf cell, restrict the usage of metal. So what it means is, so a lower level cell here, say a gate, for example, any gate, okay, you can complete the whole connection in basically metal 1 or maximum of metal 2 in some cases. Even the largest flip-flop which is given by the library, you don't use metal 3s over there. Okay, that would be an inefficient way of doing a layout. So you should try and restrict yourself trying to use M1 itself, but if not, generally in some cases of complex, what do you call, complex flip-flops or latches, you end up using M2 tracks here and there, okay, but not more than that. Okay. Try to use as less metal as possible in the lower level leaf cells. That is one most important thing. So all even number metals and odd number metals should have a particular orientation. Except for M1, M1 can be used horizontal or vertical. Okay, let me go to the paintbrush here. Okay, so M1 can be vertical or horizontal. M2 should be horizontal, M3 vertical, M4 horizontal. So all in all, from M2 onwards, all the even number metals should be horizontal, and all the odd number metals should be vertical. Why am I saying this? Is because to avoid the routing congestion. Say for example, you've got your gate or a cell, for example, and you've used your M2 tracks here. Okay, these are the tracks which you would want to make a connection. Now, for some reason in this module, you ended up using M2 vertically like this. Okay, let me redraw this again. Okay, you've got certain part of your circuit here. Okay, PMOS and NMOS. I'm just using a gate for a simple example over here. You've taken M2, okay, which you have drawn vertically like this, just to make some connection here. Okay, and now there's another module here. Okay, another set of transistors. So if at all, if I have to run a connection from this side to this side, this will block me over here. Because I have used my M2 vertically, it is blocking my routing over here. It will create a short. So thereby what happens, I have to again detour the signal and go over here. This is not an efficient way of routing, or I might have to jump to another higher metal and again go. No, that is also not acceptable. Like, to avoid this kind of routing congestions, we make a practice that all the horizontal even metals are horizontal, odd metals are vertical. And M1 has an exception because you have drain and source connections which are vertical, and some tiny, because that is still a lot more local connections what are done using M1. So if at all some signals have to talk, if at all you ended up drawing vertically, that will block the routing of other signals. So that's the reason we have this concept of avoid using uh, uh, vertical and horizontal. And on the other hand, the other thing here is it will avoid the cap as well. If you have all the metals going in one direction over here, it will lead to a lot of coupling cap as well. So if you have alternating metals like this, it will reduce a lot of routing cap as well. Okay, that's the reason we have this concept. Okay, so let's move to the next slide. Decide the width based on the signal. Do not use very thin or very wide metals. Now, as I said, you should inquire your layout person, that the lead, that okay, how crucial is this signal? Okay, if it's a normal signal, just go ahead and route it with minimum width or little more than minimum. And if it's carrying some current, or if it's a signal traveling larger distance, it's always advisable to use a little wider net comparatively, because you need to take care of the resistance as well. So all these things are there, so you have to keep in mind of all these things before you start doing the routing. And one thing to keep in mind is, if at all you are using the power lines over here. Now the other concept here is the power lines. Always power lines should be slightly wider than the signal lines. Okay, so that's another important thing, another indication over there. Okay, now gradually increase the number of metals every hierarchy. As I said just before, every level of hierarchy you tend to increase. So there's certain logic over here in this module. You've tried to finish it in metal 1 and metal 2. Just because you are not able to route over here because of you're finding it difficult, you should not be jumping to the next higher level metal and get going with it. No, you should look for all possible ways of trying and wrapping up the connection in the lower metal as possible. Okay, for a certain smaller module, unless the logic is too much and you've eaten up all the space for metal 1s and metal 2s, then you go for metal 3 or metal 4. Okay, just to facilitate your routing, don't just jump to a higher metal and get going. That's a bad way of doing a layout. Okay, and another thing here is now use symmetrical routing wherever necessary. What it means is some now, as I said, if you're dealing with a differential pair signal, you should have the routing lengths the same for both the nets, differential pair nets. Sometimes you have got this module over here and this X some module is here. There are two nets which are coming. It has to go over here. You need to match the routing lengths of these two nets. So that you need to take care when you're doing a floor plan of some delay related or timing related module. You need to balance the delays. Okay, first of all, you should try and reduce the delays. The floor plan should be done in much more efficient way. Okay, if not, at least balance it. If you can reduce the delay, reduce the routing length, very good. If not, at least try to balance it. Okay, another important thing here is you should always use the topmost metal for power supply. Why? Because that is much thicker in size as well as it has got lesser resistance. That is why in any module, for say for example in this module, okay, you've used metal 3 for routing. Metal 2, metal 3 routing is done in this module. So your power supply uh, you should be metal 4 horizontally. Right. So next, if you want to have vertical lines, you might as well have metal 5 and metal 4. If you're using only metal 4, if you want to have only metal 4 here, okay, so you need to have multiple strips alternating metal 4 with VDD and VSS. This is VDD, VSS. Okay, so try to have as many strips as possible over here. And another important thing to keep in mind over here, the supply pins should always be on the topmost metal. Say for example, if you have done the module till metal 3 and your power supply rails are in metal 4, you should always place the pins in metal 4. You cannot, just because you have a lower metal with M3 which is VDD, you cannot just place the pin on any metal and get going. No, because for LVS purposes, yes, that might go through. But if you observe from the top level point of view, the power supply comes from the topmost metal, right? From topmost metal goes to the next level below, and that is why your pin is your access point. Your pin is your initial correspondence point. That's what you need to keep in mind, that always, irrespective of whatever metals you're using for internal routing, the pin should always be on the topmost metal. And another good practice, what one should do is, whatever the pins are there, your routing should be touching the boundary here. Don't leave your pins dangling in behind, somewhere in the middle over here. Okay, it is not the job of the next level person to keep looking for that pin. So your module, you're the owner, you need to provide proper access points. All the pins should come whatever direction you have decided based on your hierarchy. The pin should be at the edge. Always make a habit, because that's not the other person's job to keep looking for the pins internally and come and connect over here. Unless you have a talk with the person who is doing the next level module, then it is okay. But ideally, if you're the owner, it's always advisable to have the pins at the edges over there. Have a proper PR boundary, have a pins at the edges. Okay, have a proper power mesh with the pins on the topmost metal. Okay, So as of now, let's stop over here, which is uh, basic enough to cover up all the guidelines. So yes, there are lots of other advanced related guidelines based on densities and antennas and max densities, all of that kind of stuff, which I think is not required for beginners as of now. Maybe in the next other modules in the coming future, we will cover all those concepts as well. So I think that's all for now for layout guidelines for beginners. That's Semiotics for you. Thank you.